All right, here we are learning 6.6, law of sines, law of cosines. So what we're going to do is this first algebra skills review. So when we see something like this, we're solving for x, we're going to cross multiply. We get 17 times 8.5 equals 24x. If I were to solve for x, and I am not going to put multiply this left side out yet. I'm just going to divide both sides by the 24 and get x by itself. And so I know x equals whatever this fraction is here. So what I'll do is now is just stick it in my calculator. So let's go to your calculator. And the reason I want you to do this is as we go along with what we're doing, law of sines and cosines, it's sometimes best that you don't try and calculate right away by multiplying on the left, then dividing by what's on the right. So let's see how we're going to do this. The first thing you need to do is make sure for this unit, or this section of notes, is that your calculator is in degree mode. We've been using the radian, but it's because we've been graphing in radians. Right now we're working with degrees on this section of units. So we're going to go to mode, and then make sure you go down here over to radians and from radians to degrees, and then hit enter. And then second mode, and go to the home screen. So when we do this, I prefer to put things in fraction form, so I'm going to do 17. One thing nice, you can just move multiplication. You could do parentheses, but multiplication was just as easy. Make sure you go down to the bottom, and you get 24. Okay, hit enter, and this is our answer. Okay, and so what we're going to do, though, is we're going to round these to 3 decimal places. So this will be equal to, let's put it over here, x equals 6.021. So again, round 3 places. Okay. All right. Now through this section, I won't be doing showing all the calculator. I'm just showing it from the beginning here so you can see. Now for number 2, if I wanted you to solve for x on number 2, what I would want you to think about is taking the square root of both sides. X is already on the left or on one side, everything else is on the other. So I can just now take the square root of both sides. What I want you to do is not use your calculator to find a whole bunch of things and then add them all together, subtract and everything, so forth. So what I want you to do is to think about just taking this right here. Since I can take the square root of both sides, I'm going to take the square root of this and the square root of this. Okay. What I'm highlighting here is that this right here, you want to put this whole entire thing into your calculator at once. Okay. Don't do it out little by little there. Just do it all at one time. And so that we will get x equals. So I'm going to show you that. Just go to our calculator. Okay, so in our calculator, we're going to hit second in this, and then I'm just going to put 11 squared plus 12 squared minus then 2, and I'm just going to use times. I don't even have to put it in any type of parentheses, because one thing nice, the calculator does order of operations for you. Okay, so I'm always going to exit out, make sure, and then when I hit enter. Okay. So again, putting all that underneath, just like I just did multiplication symbols instead of parentheses for our those numbers. So I'm doing that, and I get approximately 16.060. 16.060. And then you can leave it like this, and there's your solution. Okay. Okay, for this next one, I want you to be very, very careful. Very careful. If you pay attention, this is not exactly like the other one. I am solving for x, but my x is here, attached to other numbers in front of it, has a coefficient where the other one did not. So you need to make sure that you're careful with that and solve. This one you will take your time to solve and go a little slower to help you to do that. Okay, so let's go ahead and do that. 5.9 squared, excuse me, is 34.81. We have 49 plus 16, and 2 times 7 times 4 is actually 56. And here's my x. So again, just cleaning this up. 49 and 16 is actually 65. And then now subtract 65 from both sides. Just going to do it with another color. We get negative 30.19 equals negative 56x. And then now we'll divide both sides by negative 56. Okay, so x equals 0.53539. Okay, all right. So again, paying attention to the different kind of problems you have between 2 and 3. And all these type of algebra review we'll use when we're doing the law of sines, law of cosines. So let's go answer these questions. And the first one is, what if your triangle is not a triangle? Can you use Pythagorean theorem? Yes, no. Pythagorean theorem is only used for right triangles, okay? Can you use this mnemonic that y'all use? Okay, and again, the answer is no. This is all used for right triangles, okay? We learned this here, talked about this area here in 6.4. So we'll probably pull that up a little bit in this one. So let's talk about when they're not triangles, it's called an oblique triangle. Okay, an oblique triangle is a triangle that is not a right triangle. Now, in order to solve right triangles, we use Pythagorean theorem, and we can use, for trigonometry, you can use sine and cosine and tangent with the hypotenuse and all those different ones. But because we don't have that right triangle, we can't use the same kind of rules. So we're going to use the law of sines and law of cosines to solve these. Okay, for the law of sines and law of cosines, and again for this section, we are in calculator. Mode is in degrees. So calculator in degree mode. I know we were just put ourselves in degree mode, but again, just to kind of refresh our memory. All right, so law of sines, these are just ratios, okay? If you see here, you have 3 equal fractions. So the law of sines is simple as this. You take the sine of an angle divided by its corresponding side equal to sine of another angle, so this is B, divided by its corresponding side, which equals your last one, sine of C, with the corresponding side of C, okay? So these are just ratios, okay? So, and then there's alternate ways you can flip these and so forth. Just know that they're more than one form. So you might see me flip it over on a different way than what you're seeing, but they're all the same. So when to use the law of sines? Use the law of sines when you're given an angle and corresponding given an angle, I should say, and its corresponding side, along with a, sorry, there's a typo here, along with another side or angle. Notice that we're doing angle, angle, side here using these from your geometry. So those are all coming back. So let's kind of look at this picture really quick. So talk about, remember when you have an angle, its corresponding side's always across from it, okay? Remember that, when we have capital letters, our angles, and then lowercase letters are those corresponding sides. For us, okay? So again, big letters are angles, capital letters, and so forth. So now, when you get your information, you should have enough information to completely fill in one complete ratio and course and part of another, so that you have only one missing piece of information. So it's just saying that up here you should have like a complete one of this, and then another one over here, but maybe missing that little b. So that's talking about, okay? So what we're going to do is we're going to use that information to help us solve this triangle. Remember, when we solve the triangle, we want to find all angles and all sides. So find all angles and corresponding sides. Okay, so let's write what we given, what we have so far. So we have angle A here is 29 degrees, okay? And I'm gonna write G for given. That's information given. Angle B is 112 degrees. That's also given. We are also given this side here, since it's across from angle A, this is side A. And this is also given. And the reason I write the given, because remember, we want to use the given parts as much as we can before we can use anything. So when we set up equations, any type of ratios, anything like that, we want to try to use that. Okay, so what I'm going to do is I'm going to kind of do an order of how I want to solve these. And so I'm going to do C, angle C first. I'm just choosing 2 to be B, little b, and then 3 to be the little c. B and C could be switched, but that's how I want to do this one. So the first thing I'm going to do is look at C. Well, C is this. Big C is angle C. Well, the first thing I know in mathematics that there are 180 degrees in a triangle. So if I have 180 degrees in a triangle, I subtract 29, I subtract the 112, that will give me big C. And so that answer is 39 degrees. Okay, so now I have that. Number 2, I said I was going to solve for B, so I will do that. So number 2. Obviously, I'm dealing with the law of sines, but because I have an angle and its corresponding side and another side or another angle, well, for us, it's another angle, I can use the law of sines. So I'm going to do the sine of, and I'm going to write this out. You do not have to write this little part, but if you do not know your rules yet or your formulas, then you want to practice those. Okay, so now I'm going to fill in my parts. So I have sine A is given, and it's 29, divided by the given of 22. That equals sine of B, which I have, and that's 112, that's given, and I am trying to find B. This part that I'm highlighting for those, this is what I want to see, though. I need to see that when you're doing your work, so I can see that you've set it up correctly. I know that you can put this in a calculator real quick and get an answer, but that's not going to help you to determine whether or not you did it right. Remember, you're the error in the calculator. Remember, you're the error of the calculator. You're the one that put it in. The calculator's just doing what you tell it to do, and so therefore, if it's incorrect, it's you. So what I'm going to do here in this number 2 is going to finish us out. I'm going to cross multiply. I'm going to show this to you, but I probably won't do this for all the time from here on out. Just going to show you for this one. So I have 22, sorry. Let me go back. I'm going to cross multiply, so it's b times sine of 29, which equals 22 times sine of 112. If I solve for b, I'm going to divide both sides by this. So b equals, and this is what you're going to put straight into your calculator, okay? So I'm going to pull my calculator out so that you can see and make sure you do that correctly from here on out. All right, so here we calculator. We're going to put what is down here in this little part down at the bottom. So I'm going to do 22 times sine. I'm going to back up. I apologize. I would rather do a fraction key. That way I make sure I put the right spot. 22 times sine of 112, close up parentheses, divided by sine of 29. And we're going to round 3 places, and we get approximately 42.074. Okay, so I'm going to put this here at B. Use a different color so I know what I did different. So this is 42.074. Okay, next I'm going to find little c, this side. So now what I'm going to do is I'm going to use my given, so I've still used this, but this time I'm going to use these two. So I will still have the sine of A over A, sine of C this time over C. And so this is my third step that I'm going to do, and so I fill in my parts. Sine of A is 29, its side is 22, sine C is sine of 39 degrees, and the corresponding side is little c. So again, cross multiply. So I'm going to get c equals cross multiply, then divide. So if you always think cross multiply and divide, what do? So it's 22 times sine of 39 divided by the sine of 29. Again, sticking your calculator just like I just did, and you're going to get approximately 28.578 because I'm going 2 places. Okay, so 28.578. Okay, that's the law of sines. All right, third page is the law of cosines. This is another way to solve those triangles that are not right triangles for all the parts. So the first thing you want to look at is that let's look at each definition, okay? So we're still dealing with sides, but if you notice that we have some squares. So this might pop out as like the Pythagorean theorem and so forth. Yes, it is kind of like that, but we are having a little thing extra there. Okay, so if you're looking at the triangle like we had on the other page where it's and so forth, everything's at. So if we're solving for side A, you're going to write a squared b squared plus c squared minus 2 times bc. The cosine of the corresponding angle to little a is big A. All right? The next one is b squared. If I'm dealing with finding b squared, something with b and its corresponding angle. Again, if you notice, b squared equals a squared plus c squared this time minus 2 times ac times the cosine of b. And the last one we have here is c squared. So I'm looking at all the sides that I'm trying to find. So we get a squared plus b squared minus 2ab times the cosine of C. Now there is a pattern, so hopefully you see the pattern as you go, okay? So when you look at it like this way, if you notice whatever side, a side that's being squared on this side of the equal sign to the left, the other side has both of those other sides of the triangle squared, but you're adding them together, okay? So here I have A, so my other two sides that I'm adding together and squaring is C squared and B squared. Then I subtract, and every single one of these has a 2, okay? But we're subtracting, so we're going to subtract 2 times, and if you notice, these two letters here correspond with what's there. So it's 2 times the others, if you want to call it the others, which is the other sides that are not this one, times the corresponding angle. So cosine of the corresponding angle, okay? So every time you do this so that you kind of see a pattern. I mean, really, if you get this first one down, you just have to interchange the A. If I go down B squared, then just change B with A squared. You go down here to C squared, change C squared with the other one that you don't have, okay? So anything like that to help you to kind of memorize it, but that's the formulas for that, okay? So when do we use the law of cosines? We use the law of cosines when you're given all 3 sides, which is side, 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 or an angle and the 2 other sides, which is side, angle, side, okay? We have no corresponding angle and sides when you're using the law of cosines, okay? There's nothing that we're going to use the law of sines. So I believe on your notes it might be, but this is what you need to use. We're using this triangle for this example, okay? And so what we're doing here is we're going to put down our given parts, and then we'll go from there. Okay, so we're going to solve for all the different sides and angles that we need to. Let's kind of first make sure, see what do we have given. So angle A we don't know, angle B we don't know, but we know angle C, which is 37 degrees. That's a given. We have side A. Well, side A has to be here because it corresponds, it's across from the angle A. And then B would be here. So this is your little b. So, but we are given for A, 14, little a, 14. And then we're given B to be 16. And we don't know C. So let's find the other missing parts. So how I'm going to do this is when you're thinking about having to do the law of cosines, you really need all 3 sides first, because if you're given the other 2, only because you're not able to do such things. So you have to have the 2 other sides at an angle. Okay, so you should be able to find the 3rd side using the law of cosines. So I'm going to do that one first. I cannot find the angles until I've used that. So I'm going to do this first. Then I'm going to go with number 2 to be A, and then 3 here. Okay, so number 1, I am looking for C. So side C, I thought. So I already have the angle. So I know that I can use my law of cosines. My law of cosines, the reason I'm able to do this as well, if I write down what I'm looking for, I'm actually looking for C squared. And if I think about what I'm looking at, I'm going to write this out. If I have all the information I need, remember, I need one unknown. That's what I need. When I'm doing all these, I always need one unknown. So my unknown is my my side here, okay? So if I can fill in all the parts on here and just have one unknown, then I can solve it. Remember, for every unknown you have, that's how many equations you have. And we only want one equation, because then we're talking about systems, and we're not solving systems here. So if we look at this, I have to have all the parts that I need. So I don't have C squared. I do have A squared. So again, you do not have to show me this first step. It's always recommended that you do. but you need to show this next part where you're substituting everything in. Okay, so a squared is, a is 14, b is 16, and I'm minus 2, oops, 16 squared, excuse me, 2 times a times b times the cosine of a, and a is 37 degrees. Okay, so now remember, if we have the c, or the variable that we're solving for, on one side by itself and everything on the other, we're going to just take the square root of both sides. And in our calculator, we're just going to put this part that right here. All of this will go, whoops, straight into our calculator. Okay, so take the time to do that and come back and see what you did. All right, so I got 9.706, so I put that in place of C. So I want to remind you what I expect. I expect this whole thing right here, you don't have to highlight it obviously, to be put into, I need you to see it on your, so that you can see that you're showing that work. All right, so that was the first one I did. The second one I'm going to do is find angle A, okay? So let's find angle A. So for number 2, since I'm dealing with angle A, I'm going to have to use this formula. A squared equals B squared plus C squared, so the other two sides, times 2 times the other two sides, times the cosine of A. Okay, so fill in your parts. All right, I have A squared. A squared is 14, so this is going to be 14 squared, equals B squared is 16, and C squared is, now these are given up here, and we use all those, but we obviously have to use the third side. So this is going to be 9.706 squared minus 2 times 16 times 9.706 times the cosine of A. There's our unknown. We have to solve for A. Okay, so I did the math all up to here. I moved this up this way. And so I want to kind of show you how this next step to make sure that you making it much simpler in your life when you put it into your calculator. So when I do this, I'm going to get to this point. Now I got to divide both sides by negative 310. I need to find the angle A, and angle A I cannot find if that's in front of it. Okay, so don't put this in your calculator. We know a negative times a negative is going to make these positive. Divided by a negative. Negative divided by negative is positive. So I'm looking for cosine A. So cosine A equals this. 154.206, 310.592. Now, how do we find the angle? Remember, we are to use cosine inverse. Okay, put this fraction here, and that equals angle A. I'll give you degrees. All right, I'm pull my calculator up and show you how to do that to make sure that we remember how to do that one. All right, so I'm going to put this little part here into your calculator, inside here, put that in there, and put all this in there, okay? Not the A, but that. So what you do is, remember, you're to go to second, and the cosine inverse key is this in blue under cosine. That will pop up. And then we're going to put a fraction there. Again, I'm just going to always do a fraction key. So it's 154.206. Now this answer, this number in here should be positive. Even if you put the negatives in there, it'll reduce it to, obviously change it to a positive. But sometimes your calculator can get finicky. It doesn't like that. Okay, your answer should not be negative because we don't have negative angles. So if that happens, you'll get an error anyways. So we enter, we get approximately 60.2319. Remember, we are to round angles to the nearest degree. Okay, so now we have our angle to B. So A is equal to 60 degrees. Okay. And then if we look at the next part, so we can easily find the third side. I'll get this out of the way. So we find the third side by looking at the angles. So I have 37 degrees and I have 60 degrees. So the third thing that we'll do is we'll take 180 minus 37 minus 60 degrees, and we will get 83. So that's B. So this is 83 degrees. Okay. All right. Our last page, let's look at this next example. It says, give the following triangle, find the measure of angle C. Notice that we're only finding one. So we are looking for angle C right here with that degree. So remember, that means we have to do sine or cosine because it's not a right triangle. So we'll do one of those laws. So if you notice that we have three sides, you cannot do law of sines, because we don't have a corresponding angle. So because we have three sides, no corresponding angle, we're going to do law of cosines. So since we want C, we have to use C squared first equals A squared plus B squared minus 2 times A times B times the cosine of C. Okay. So now we just make sure we know that this is C, little c, here's my A, little a, and here's my little b. All right, so substituting what we know. We have 10 squared equals 16 squared plus 8 squared minus 2 times 10 times, oops, sorry, not 10, times 16 times 8 cosine of C, which is what I'm looking for. Okay, so now this is 100. This is 256 plus 64 minus 256 cosine C. Okay, now solve for angle C. Okay, so as you can see, I did the math, went through, make sure again that you understand that, remember, this side cannot add that together. So I subtracted 320 from both sides, got negative 220, and then over here is I just divided out and it's positive because negative divided by negative is positive. Don't forget to use the inverse key, and then the fraction goes in there, and so round to the nearest degree, so you should have got 31 degrees. Okay, so like I said before in the beginning, I hope I said this, but if I didn't, we use a lot of application with law of sines and cosines, and so we're going to do a few that we would use, that you would see examples of them. So here is Juan and Ramela are standing at the seashore 10 miles apart. The coastline is a straight line between them. Both can see the same ship in the water. The angle between the coastline and the line between the ship and Juan is 35 degrees. The angle between the coastline and the ship and Ramela is 45 degrees. How far is the ship from Juan? Okay, so best thing to always do when you do these is draw a picture. So I'm going to draw a picture. I know it's kind of silly, but I'm going to use, there's some water. Okay, here's my water. And so I have one here, just standing here. And then here is Ramela. Okay. So what they're doing is that they are, according to this, are standing at the seashore 10 miles apart. The coastline is a straight line between them. So I know I can draw a straight line here. Okay. And then both can see the same ship. So we have a ship that's up here. I'll make this ship green, I guess. So I'm not, something like that. Here's a ship. And they are standing, they can see them. The angle between the coastline and the line between the ship and 1 is 35 degrees. So that means I have to draw between 1 and the ship. And this angle here is 35 degrees. The next statement says the angle between the coastline and the line between the ship and Ramella is 45 degrees. So between them two is 45 degrees. And we created our triangle here. Okay. And they want to know how far is the ship from 1. So we are actually looking for this right here. This is what we want, X. X marks the spot. So now, let's see what we can do. So we don't have enough sides to think about the law of cosines because I don't have any numbers. But if I do know that if I have 35 and 45 of the triangle, then I can find this other angle up here. Okay, up here by the ship. So the angle that between them. So if I do that, what is that? That's 180 minus 35 minus 45, and that gives you 100 degrees. Okay, so that's 100 degrees right here. And so since that's 100 degrees, I know all of them. I have an angle side angle, so I actually can do that. But what else do we know, though? We know that 1, and I missed this part, 1 and Miller are 10 miles apart. So I do have a number. So I have an angle with a corresponding side. So I'll use the law of sines. Okay, so now law of sines. So I have the 100 and its corresponding side. So I will do the sine of, I want it in that. Let's erase this part. So I want the law of sine of 100 degrees over 10 equals, and since I want to find x, I'm going to have to use 45. Sine of 45 degrees over x. Again, that's what I want to see. I want to see the setup before you put in the calculator. Now just use your calculator and find an answer. Okay, so when I get done, put this in my calculator, and I get 7.180 miles. So 1 is 7.18 miles away from the ship. So we're going to round 3 places when we're doing these things. Okay, unless it's an angle, it's the nearest degree. Let's go to the next problem. Okay, we have 3 boats at sea, Jenny 1, Jenny 2, and Jenny 3. The crew of J1 can see both J2 and J3. The angle between the line of sight of J2 and the line of sight to J3 is 45 degrees. If the distance between J1 and J2 is 2 miles and the distance between J1 and J3 is 4 miles, what is the distance between J2 and J3? Again, I would always try to draw a picture. So I know you can just draw triangles, but I'm just, for effect. Here's my water. I have 3 ships, and I'm just going to label them J1, J2, and J3. It says Jenny can see both of these, so that's why I drew it this way. So we have this triangle here. Okay, so a nice triangle there. And then it says the angle between the line of sight to J2 and the line of sight to J3 is 45 degrees. So I'm seeing 2 things that I'm looking at. So 2 ships I'm looking at. So the angle has to be from the same place. So that angle has to be right here, 45 degrees. Okay. Where's my degrees looks large. Okay. The next thing is the distance between J1 and J2 is 2 miles, and the distance between the 2 is 4. So this one is between let me do it right. J1 and J2 is 2. J1 and J3 is 4. And we want to find the distance between these 2. Since I don't have an angle with corresponding sides, I'm going to use the law of cosines. So I have no corresponding angle inside, use law of cosines. Okay, now since I want this and have this this is what I need, so that has to be a side, so we're going to start with that one. So we have x squared equals each of those sides squared, add them together, minus 2 times those sides, the other sides, than the x, so 2 and 4, and we're going to take the cosine of that angle that's across from x, which is 45 degrees. So again, one thing nice, you're just going to put this all in your calculator like this. And when you get done, you get x equals 2.947. Okay, so J2 and J3 are 2.947 miles apart. All right, number 3. Jill is standing 400 feet from the base of a mountain with an angle of elevation of 25 to the top of the mountain. Jack is standing 500 feet behind Jill with an angle of elevation of 20 degrees to the top of the mountain. How high above the ground is the peak of the mountain? Now, when you look at this, you want to find out, what am I ultimately looking for? What is my thing that I want to know that I'm searching for? Is actually this. This is your height of your mountain right here. So if hopefully you notice that inside this, where the H is, I see a right triangle. Okay. And if I think about the right triangle trigonometry that we've been using, I can actually solve this and find the height if I knew the hypotenuse right here, the hypotenuse, if I knew what this was, or if I knew what the base of this triangle was. So if I have that information, then I'm good. So let's see if we have the information. So let's go back to what we have. So the first part says Jill is standing 400 feet from the base of the mountain. So be very careful to understand the base of the mountain for Jill is right here. It's not all the way to that height. It only goes right here. So this is 400 feet. Okay. So that's extra stuff we don't know. So here I don't know what that is. So I can't use this to help me find the base, using this to help me find it because I don't know X and I don't know the whole thing. So I can't use like tangent. But if I knew maybe if I found the hypotenuse, if I was able to find D here, this D, I'm called D, then I can find that. Okay. So if I look at what I have, it says Jack is standing 500 feet. So this is Jack back here, and this is Jill over here. That's not really much we need to know. So let's see if we can use that. So if I know what's inside here, what I have in here, in this triangle, I can think about using this triangle to help me find D. Because D is opposite, it's a side opposite of the 20 degrees. So if I have and I have another part, so I can literally find this angle here if I knew what all of it was. So I have to be careful and make sure I know what that angle is, because I already have one known as D, so I got to know what that angle is across from 500. So one thing I think might be helpful is if you draw this triangle again. So let's draw this triangle again without all that extra information that we don't need, to see if that'll help us. So let's redraw it. Okay, so what I did, I do just the parts of the triangle that I need for this. Oh, and again, I'm going to call this D here. Okay, so again, since this is a right triangle in here, and that's what we're looking for, and we have H right here. So because this is a right triangle, think about using, this, your right triangle. Okay. So like I said earlier, this triangle right here is what we need to help us to find D. This right here, the one in blue. So remember, if we're going to do the law of sines, we discussed the law of sines because we have an angle and a corresponding side. And if we can find the other angle, the other ratio, then we can do this. So what I need to find, I have 500 feet right here. So if I can find its corresponding angle, which is way up here, this angle right here, then I can use the law of sines and be able to find D. Okay, so the thing is I need that angle. I don't have it. I have to know it because of my law of sines. So first we're going to use the law of sines. Okay, and that's because we have a side and a corresponding angle. Okay, so if we think about our geometry, we need to think about how it's the angle here. If I find this one, then I can find that one. So remember in geometry, this is a straight angle. What I have created, right, that's a straight angle. Okay, so that straight angle is going to help me find the other angle. So when I want to find that, I'm going to take 180 degrees, I'll do it right here, minus the 25, and that's going to give me 155 degrees. So this angle right here now is 155 degrees. So because it's 155 degrees and that one's 20, I have this one and this, I can find this. So with that, I just take all those two sides, or those two angles, excuse me, and subtract from 180. So I'll just do that here. 180 minus 155 minus 20 degrees equals actually 5 degrees. So this angle up here is now 5 degrees. So now I have two sides with corresponding angles, therefore I can use the law of sines. So we have the sine of, let's do 5 degrees over 500 equals sine of 20 degrees over d. That's what we're looking for, is d. So d equals, remember if you cross multiply and divide, should look like this. And d equals $1,962, $1,962 and 121 thousandths, and that's in feet, not dollars. Excuse me about that. Now that I found d, I can use the right triangle information. So I have an angle, I have the side opposite, and I have the hypotenuse. So I'm going to use sine. So number 2, our right triangle, trig, that's what I'm going to call it. I'm going to do sine of an angle equals the opposite, which is h, over the hypotenuse, which is d for us. So that's 1962.121. So h equals you substitute that in your calculator, and you get the height to be 829 point, we're around 3 places, 228 feet. Okay, that's how high the peak is.